Aha. Morning. Thanks for turning up in such great numbers. I guess everybody else is drunk still and sound asleep. This presentation is called Surviving a Primetime TV Commercial. It works like this. You switch on the TV, you watch it, and you try not to die. Okay, so this is about actual software things. My name is David. I have an umlaut in my name that you might find strange because it's actually spelled like this. I am German. Most countries don't use weird non-ASCII characters unless it's really weird languages like Chinese and stuff. I come from Germany, from Munich to be more precise, where the weather is currently as miserable as it is here, I believe anyway. When I left it was raining, etc. The only thing is that we have the better beer than Portland, clearly. I work there as the lead architect for a company called ENVS Technologies, actually a holding company, so it's an investor. And this is their technical incubator, so their investments get implementation and other technical help from us. I used to do consulting before that for quite a few years, but at some point I realized it's actually really boring if you just sit in a corner and tell the client, yeah, that's a good idea, or no, that's a bad idea, and then you run away, and by the time they figure out if you were right or wrong about what you told them, you're already gone to the next project, and you can never claim that something is yours because you built it. This is me on Twitter, and so to tell you what the challenge was first, this microphone is a little bit spotty. I'll try this. If this is a problem, I have to stop pacing, because usually I pace on stage like a tiger in a cage, right? This is not a very large cage, so if I was a tiger, I would be really grumpy. Okay, I'll be closer to the microphone from now on. No more pacing for me. The challenge is, or the project we're currently working on is a website called Kiveda, is what the Germans say. Kiveda is probably what the rest of the world would say. They sell kitchens online. In itself, that's a relatively interesting business because kitchens are not your average products. They have, first of all, you don't have them in stock because you'd really need a really big warehouse. So they are produced on demand and then shipped to the customer, who's hopefully happy with things. Unfortunately, in the real world, these are complex products, so upon delivery, someone will always figure out there's a scratch in a door, etc. So that's like a whole different set of problems that I don't want to get into in too much detail, right? Because surviving the commercial by making sure that your website remains online and you can still sell things is only one part of the equation. If you don't have your supply chain in order in e-commerce, then it doesn't help you because you get 10,000 orders in, but if you can't fulfill them because half of them are gone, we've had issues where payment providers blocked too many people who wanted to pay in installment payments or with invoices, and we didn't realize it for a while. That's bad, right? You lose business. What happens if the door on a cabinet is scratched? Do you reorder the whole thing? It doesn't even have a product number that you can put in your database, etc. So automating that is difficult, but I don't want to talk about that today. I want to talk more about like the website part of things because we do web development, I think, or most of us anyway. So this website was, up until very recently, just running an off-the-shelf e-commerce solution, which is a reasonable thing to do if you want to sell things online. So you get something like Magento or another software that already exists out there. You customize a few templates, you make sure you have your payment provider modules installed, etc., and then you launch it, right? And that is really fine until suddenly you decide to air an ad on TV during prime time hours. Because at least in Germany, so it's going to be a lot bigger in the United States, but in Germany, this will get you usually around 10,000 unique visitors within a minute or two of the beginning of your commercial. Unless it's a really long commercial and you only mention it at the end, then it's going to be 2 minutes after the commercial. It doesn't matter. They all arrive in a very compressed amount of time, right? And they start clicking around on the website. And before you can count to 3, which with a standard off-the-shelf software, we run Oxid. That's a PHP-based shop solution, mostly popular in Europe and the German-speaking regions. All your visitors see your error page, and then after a second, they only see a white page, because even that goes down, right? Because usually, like, this is a dramatization, and the numbers are completely made up. But what it will look like roughly is, you know, like it's just humming along because people are watching TV. This is like a big channel. It's a blockbuster film on Sunday evening, let's say. Right. Oh, and by the way, I have dual lasers. This is pretty cool. So one is more powerful than the other. So this is time. This is how you correctly use 24-hour notation. Just for those of you who are used to PM and AM. Don't be confused, okay? So this means 8:44 p.m., okay? This means 8:45 p.m. And this means, okay, you get it. Anyway, so people, like, you get, this is not exactly 0, but I was refusing to use a log scale because that makes it look stupid. But, so you get like a few dozen requests, right? And then all of a sudden this thing airs. And they show the URL. It's actually really funny if you then look at logs and analytics, how do people actually get to your website? Because only a part of them types your website, your URL directly. Like most people nowadays, you know, type a URL into Google and click the first hit because it's people, and then lots of misspelling, and sometimes they type complete claims and sentences from your commercial into Google. So you need to optimize for that. So if you ever want to run a TV commercial, make sure that the things you say in your commercial are actually, the catchphrases are also somewhere in your meta descriptions, etc. So Google picks them up. Because people will type, buying kitchens can be so easy, because that's the only thing they remember. It's actually true, it's like, seriously. So, and it gets worse, and then after, like, slowly it starts ebbing, right, ebbing off. So as people, because you get, like, lots of individual users, almost all of them will hit the front page. That's a really good first thing to know. Then they start clicking around. Some will just, you know, go and see what is on offer there. Some will start configuring a kitchen, which is a challenge in itself because you can't have that in your database as a product. In every permutation of 50 different handles with different colored fronts, with different cabinets, etc. So we also run, for instance, servers with graphics cards in them that use for clients that are not WebGL capable will render a 3D representation of the kitchen as people start changing options. So they go, well, I want a bright red door and not a blue one. But that part, for instance, is not mission critical, right? If that fails, it's not as bad as the front page disappearing. So anyway, this keeps happening, and you can take bets on what's going to happen first with a standard off-the-shelf solution, because it's either going to be Apache eating up all your RAM if you run Apache. Like, this is assuming that you do the standard setups that most people are used to when you, without lots of technical knowledge, launch one of these shops, right? Clearly, we know better than that, but like I'm showing you the steps that people usually go through. You hit the MySQL connection limits, like some sort of disk access trashes I/O, and the load spikes, and then you're doomed. Everything's bad. So that's bad. We don't want that to happen. This is the situation we wanted to avoid. The good news is that TV ads during primetime hours don't actually happen suddenly, but instead they happen at a predetermined time. So you know down to the minute, well, not roughly, like plus minus a minute, when it's going to air, which is really, really useful, because theoretically you can add capacity if you host in the cloud. I'll get to that in a moment. That helps, right? But you still need to make a scale. So the question is how. And for standard e-commerce shop software, that you have basically two options. The first is you invest in more hardware and in some sort of proprietary caching solution. This is what all the Magento, et cetera, enterprise editions there's hosting companies who specialize in these things, so for an insane amount of money, they will sell you a really simple, at its core, really simple caching solution that's probably going to break once you start customizing one of the templates in the system, etc. Right? So you need to deal with like a lot of this great code that might fail. And of course, it incurs like an insane amount of license costs, because for every server you add, as you add capacity, you need this, not just the physical hardware, but the license to run the shop software for the modules for payment provider integration, ERP, system synchronization, the caching solutions, etc. So that's per server. And this is the thing that was relevant for us, is that you need to do that for every shop you launch, right? So right now, this is a kitchen project. What if we, in the future, and we will, have other businesses? Completely different things. Maybe we'll sell, I don't know, elephants would be cool, I think, like actual physical elephants. Because like logistically, they're really a challenge if you think kitchens are difficult. But, or maybe we'll start selling shoes or something else. So you could also build it yourself in that case, right? Because it's a big investment up front and it needs maintenance over time, obviously. But you can actually pick a hybrid approach where you say for the actual checkout process, for all the payment integrations, for all the ERP synchronization, et cetera, you use the existing solution that you already have. And this is what we went with. For that, we also defined a few goals. These are technically not our goals, but the CTO's goals. I'm really happy not to be a CTO, because like any C-level position means you only sit in meetings. I only sit in meetings, but I also get to think about technical details, so that's a little bit more fun. So he said, like, I want this and this and this. So one of them was like any page, not the home page, but anything that like is closely related to selling. Anything must be served in less than 100 milliseconds, always no exceptions. And we said, okay. Another wish that we personally had, like amongst the developers, was we try to degrade and not to fail under extreme load. But if we had to, we would say we prefer failure for some users, so like error pages, etc., over like the whole site being insanely slow for everybody. This is simply a matter of like how do you cache, how do you configure your engine access, like your fast CGI processes, etc. So that's relatively easy. There's some things you can do to facilitate that at a software level. And another thing you can also do is you can sacrifice freshness of data and features for performance, right? So you say, if I'm under really high load, I start delaying writes, I start delaying imports, because like every little bit of capacity that my database, for instance, has helps. So this is, by the way, one of the reasons why for anything that doesn't have to be super timely on a website, you should always use ways of queuing that and processing it asynchronously. Gearman comes to mind, or use something like beanstalkd, where you can just put something on a job queue. And if you notice through some sort of monitoring that the load system goes up, you can start slowing this part down because it's not so critical. Right? So some sort of like degraded modes for the site are really preferable. And another thing we wanted to do was replicate any change in the product database, because we still maintain the product database using the standard shop software, right? We want to replicate that to the new fast front end. We call it Fox, because foxes are fast animals, I guess, and it's a faster than Oxid solution in less than 60 seconds. One thing I personally, like this was just my decision, I informed everybody and they nodded and laughed, said, if I don't want to worry about the checkout process actually going down, or the shopping cart. Because if the shopping cart is, we're selling kitchens, right? So they are actually high-priced. This might, by the way, be something for you. In Germany, at least, if you move into a place, there's usually no kitchen there, often even if you rent a place. So the landlord doesn't give you like a really cheap kitchen. People go and buy like a nice one or a not nice one from IKEA or another place, a kitchen manufacturer, and install it themselves in their apartments, whether they own the apartment or just rent it. So anyway, we sell kitchens. They have high profit margins. If we sell so many kitchens that whatever number of web servers we have for the checkout process goes down, I'll open a bottle of champagne and celebrate and call it a day, because that means we sold a lot of things, right? So you need to like pick your battles. Selling too many things is a really good thing in many situations, especially in this case because every time an order comes in, you can't completely automatically hand it off to some sort of system that will process and fulfill the order. We do that for any accessories we sell, so you can buy dishes or you can buy pans, cutlery, etc. For that, it's fine, right? We do it in an automated fashion, but any kitchen that's actually purchased on the website goes through several manual verification steps. So you actually want that to be at some kind of a bottleneck. This is what I mentioned earlier. You need to have your supply chain and the processes in the company also in order. Because if you need like several hours, which was the case for us in the beginning, to just go process one order with like several people, then it's difficult. So speeding that up was also a really important part for us, making sure that like if a customer orders something, we can handle it quickly. Anyway, for these goals, we need, ideally, this is like me, the engineer, right? Like this is what I want. A share nothing, or at least a share little architecture. You want failover configurations where they actually matter, right? So, and these are things you can test. These are even things that your developers can test on their local boxes. I'll tell you how later, like how we did this, for the parts that matter. For instance, the load balancer and your caches, your SSL termination. Usually with these sites nowadays, you have some sort of load balancing in a redundant configuration that probably in there or before that you do SSL termination. You need to decide where do you put your cache. And then at some point, you probably hit an application server where you want a database that is capable of full-text search, which is really important, and a lot of other things because you want to filter. In case of kitchens, it's the same thing for shoes. There's a lot of permutations for selection. So you have colors, you have sizes, you have styles, price ranges. Is it an L-shaped kitchen or just like a row of cupboards? Does it come with or without electric appliances? What sort of electric appliances? So there's a lot of permutations, and you need a database that can do that. And ideally, you don't hit an app server at all for the standard cases of front page, maybe product details, etc. So the question we were facing was, do we use traditional hosting or the cloud? I like the cloud. We were not allowed to host everything in the cloud, simply because that was a management decision to say we don't want to host everything on Amazon because we think that's too expensive, et cetera, et cetera. And we already have existing hardware. So we had existing hardware that everything was running on with actually managed hosting in our case, so we don't even have root access to the individual boxes, but it's not shared hosting either, where we have to make do with a standard configuration. So that was option A, host everything yourself. Then you can say, well, some parts I could certainly move to the cloud. I met a guy in San Francisco a couple of years back. He was working for Adobe, coming from Scotland, was very drunk and very high, and he told me that what the cloud was interesting. He said, so I will not imitate the Scottish accent, I can't do that. So, or maybe. So he said, you know the cloud is when you have a Windows computer and you have a Windows, and then in the cloud there is a Delta with Windows and Photoshop. And the cloud, you can install any program from the cloud to your computer with a Delta. And I said, but the Delta between a Windows and a Windows with Photoshop is just Photoshop, right? So you download Photoshop from the cloud? No, just the Delta. And he kept talking like for 15 minutes and telling me I didn't understand the cloud. So the cloud is actually, in our case, this is, because most people say consumer things, cloud, storage, etc. But what I actually mean in most cases when I mention this here is infrastructure as a service. So you don't have to go all the way to that. You can say use software as a service, for instance, things that aid you with logging or emails or anything else, right? So at least you don't have to do that yourself on your own hardware. You can clearly host some parts yourself and other parts on AWS. That's a viable option. There are features like even Amazon Direct Connect, if you want to do crazy things like hosting your database on your own hardware, and any web front end on S3, which in this case actually would make a lot of sense. We were just not allowed to do it. Like we considered it at some point. Or you could host everything in the cloud. For a while, we considered option C in a configuration where we would have a couple of servers that always serve front ends, and then on-demand instances, because we know down to the minute when the traffic spike's gonna come, right, on S3. Forget that. That doesn't work, ever. So you can't say I have a few front ends that run some sort of database, and then I bring new instances up on EC2, because it takes you a lot of time to replicate all your data to EC2. Then you need to make sure that all the instances on EC2 only hit the local nodes, the instances that run on your own servers only hit those nodes. You need some sort of global load balancing. You need to make sure that someone puts something in a shopping cart, it still ends up in a data center. You pay for all the traffic 5 times, it's not worth it. If you want to do that, then either go all on your own hardware or go all in the cloud for one part of the system. Mixing it is really, really difficult in many cases. So we decided not to do that and ended up with the option where we don't host any computing instances on EC2 or something similar. It's all written in Symfony, obviously. This is a keynote, and it's 8 in the morning, and I'm not going to bother you with code. Also because I don't write a lot of code anymore. I'm the architect, so I haven't written much code so far this year. We all know why it's great. You have a community. It's really easy to get talent. We had an existing pool of developers who knew both Symfony 2 and Oxid, so that's the shop software that we use for the checkout process, etc. And they, so it was really like a no-brainer. The abundance of bundles and everything that you can get for it, it plays nice with Varnish, all these things, right? And like it has just the community drive behind it, so it's clearly a good choice, the best choice. Like 2 special mentions that I should say is what we make heavy use of is bundle inheritance. So it's not one application. It's actually what we, a site like Kiveda actually consists of like dozens of vendors that all pull in like little bundles that have been customized, sometimes in the application using bundle inheritance, because what we have is we have a bundle for products, we have a bundle for search, we have a bundle for just browsing a category. These have default templates, they have default control implementations. So out of the box, you can actually say, hey, we have an idea for some sort of e-commerce business, and you can deploy something. It's not going to look nice, but it's going to work, right? And then the actual code for this kitchen website inherits from these base bundles, maybe adds a few functionalities here and there and controllers, and overrides a lot of templates to make sure that everything looks the way we want it to look. And the other really useful thing was Twig, because we actually use this to share, at least in some parts, templates between the front-end code and the checkout process part in the old legacy application, where we said we're going to migrate from Smart to Twig templates and share those, because it's a lot easier for designers. They don't have to learn 2 template languages, etc., when they want to make a change. So that's all done. We write it with Symfony. Now the big question is where we store our data. Then we have a bunch of options. You can try it with MySQL, which in this case is actually not a big deal, because as I said, we don't store permutations. So we're talking about thousands of products, not millions or billions of them. I could use MongoDB, but over my cold dead body. Even though it's web scale, I'm not a fan. CouchDB, etc., are other viable options, but what we needed was full-text search as well. So we went with a much simpler solution saying we store everything in Elasticsearch, right? Because you don't have to use it just for search. More and more people are using both Solr and Elasticsearch actually as a storage for everything. So our entire product database with all descriptions, pricing information, categories, etc. details lives in Elasticsearch. And one kind of important feature, or one nice thing about Elasticsearch, is that it gives you something that I listed in the requirements earlier, if you remember. a share-nothing architecture. Because Elasticsearch, I don't need redundant power supplies in a master MySQL data. Well, I still need that for the shop, right? But in this case, you have a bunch of nodes. You add a new node. It starts doing its replication thing. And you have the redundancy and the high availability built in on the software level. That's valid for both Solr 4 now has its cloud mode or clustering built in. Elasticsearch was always designed with this in mind. And with modern technologies such as Zookeeper, et cetera, like it's really no big deal. Like you don't get split brain situations, or at least not severe ones. Extending the cluster is relatively easy, although Elasticsearch and Solr both come with their own share of pitfalls. If you bring up nodes, it sometimes does crazy things with replication, which is one of the reasons why it's not really trivial. It wouldn't have been trivial to say, we always have 2 web servers that run this stuff, and then on demand, we provision instances on EC2 and try and replicate the whole database over it. Because Elasticsearch, and the same is valid for Solr, they don't have, you can tell them what rack a database node is in. So it will make sure that when it stores replicas of some data, it won't store all the replicas on the same machine or even the same rack, right? Because if your rack switch dies and all the replicas for part of your data is all lived in that rack, the data is gone. So this sort of rack awareness, a lot of distributed systems, Hadoop's DFS has that as well, are useful. But what you can't tell Elasticsearch is, here's a wide area network connection between my data center and the cloud, EC2. So only, like, don't simultaneously replicate several bits of data or the same shard of data over it, but make sure that you use that connection efficiently. It doesn't have that. It has a special feature for Amazon's EC2 availability regions that we maybe could have hacked to do that, but we at the end decided it's just not worth it. Let's just not do it. So we had to replicate from MySQL to Elasticsearch, clearly. What we ended up doing, we thought about a few things like poll all changes, somehow query the database all the time. But the easiest way was to just put triggers in place on the existing tables that store category information, product information, etc. They write to some sort of a simple log table. We thought about, we could use a Gearman plugin to create a Gearman job right away. You can't do that. I'll tell you why in a moment. Or stuff like that. But we just ended up writing to one InnoDB table that has the information about a change. And then a Symfony command line script, of which we use quite a few, runs periodically and reads all the records from that table and sees, oh, a new product was created, a product was updated, and replays that change or whatever that operation was in the MySQL database on the Elasticsearch cluster. The nice thing is you put that into a transaction. You can identify items by ID in Elasticsearch somehow. So if an operation fails, you can really easily pick up where you left off because the transaction didn't complete. You delete every record from the table as you process it. And we then use supervisor-d, which is a really, really useful tool for exactly these sort of things to make sure that this script keeps running. Because it shouldn't run in an infinite loop, and then you need to do monitoring. When does it run out of memory? Because sometimes PHP has its mem leaks in some sort of situation. So what we ended up doing is just use supervisor-d to make sure, if we run a cron every 30 or 60 seconds, it could be that a script one of these, one of these incarnations of the script or whatever runs very long, and then the crons run in parallel, overtake each other, etc. So supervisor-d, whenever you need to make sure something remains running, is a really useful tool. It will check exit status of a script. So if something fails too many times, it will raise errors for your application logs, etc. And we also send a purge request and maybe even a get to pre-warm again to varnish. You can't use Gearman for something like this because, well, you could try, but it doesn't make any sense, especially because the assumption is that you don't replace your whole product catalog 5 times a day, so you don't have a lot of writes actually to the product database. But with Gearman, the thing is that you have several workers running at the same time, and maybe one of the queues is really busy right now, and that busy queue gets the create operation for a new product, which was immediately also updated, and that update queue, worker queue, is empty. So you have an update all of a sudden going into Elasticsearch for a product that doesn't exist with a correct price. And then after 5 minutes, the create of the product in the database arrives with the wrong price. And then you have an inconsistency in the data you have. So we did that. This already got us like a really, really fast system where we would have product details, category searching. It actually almost didn't matter because you need to throw a lot of load Elasticsearch to make it go slow. Obviously, certain optimizations and settings you can always tweak to, in the index and the configuration to make reads fast. But with this, we were already seeing with a little bit of optimized code, et cetera, and APC on, about 120 milliseconds on the server side maximum for one request, which was already really close to the goal. And then we started caching. You can't cache everything, obviously, but you can cache as much as you can. Or you should with Varnish, which is straightforward, I guess. The golden rule, you know, strip your cookies, set the correct headers, the lifetimes and cache control information, etc. From the application, obviously, need to be correct. Then you use Saint and Grace mode, and then it's done, right? Like, no problem. Well, almost, but users have shopping carts, obviously. So you need to deal with that situation. You want to show the correct amount in the shopping cart, the sum in the shopping cart, and you also, if somebody's logged in, it should say in the top right corner, you're logged in as. For that, you have 3 options. You can either say, use edge side includes for these parts, right? So you hit some sort of different, maybe slower session backend to figure this out. You can use XML HTTP requests. That is easier on the application level because you don't have to do anything there, but the client might need a little bit of, you know, it takes maybe a couple of milliseconds until those requests come in, so you have flashing things on the website. And you need to, in modern browsers, deal with cross-origin concerns, even if you're just trying to read the shopping cart from HTTPS over an HTTP connection. This was a concern for us in other places as well, the whole course thing, because what we ended up doing, for reasons that are way too detailed to go into right now, is we actually segregated traffic by protocol. So we said anything that's over HTTP goes to the really fast front end, and anything that comes in over HTTPS is always assumed to be something that concerns the shopping cart, the checkout process, the customer account, a login functionality, something like this. Anywhere where we have confidential data, and we would send that to the to the existing shop software, which still runs Apache because that's what they officially support with all their rewrite rules, et cetera, and so forth. What we then did, put an Nginx proxy in front that makes sure that only certain URLs are actually passed to Apache, because then you have the same problem again. Someone publishes a wrong link with HTTPS in front, and the site still goes down because you simply launch too many Apache processes with mod PHP, etc. You could also use signed cookies if you want. Those are actually also a really good option for a shopping cart, etc. But maybe you want to validate on the server side that the user's actually logged in because you want to see the user hitting your backend every single time. So if you want to do option A with ESI, then if you simply have an include for the shopping cart to show the contents of that, you don't really gain anything, right? Because then on every request, you have the ESI sub-request from Varnish that can't be cached to your application backend, which is probably the slow shop software, and that creates a process, and then the site still goes down. So you need to make sure that you only hit the shopping cart's functionality for people who actually have something in the shopping cart. So you can, for instance, simply set a marker cookie when someone puts something in the cart, and you have an include somewhere in your page to the contents of the cart that will render maybe just the sum in dollars or euros in our case, and show how many items there are. And then if the cookie exists, you want to hit the backend. If the cookie does not exist, you simply in VCL fetch in Varnish, you rewrite that URL to empty cart.html or something, which is like a $0 static page that has the caching information so it can be cached forever. And that way, you can make sure that only people who have the right cookie set that indicates to Varnish that some of the requests should be passed to the backend to actually hit the backend. And you can use the same trick for someone who's logged in. You just need to make sure that you don't use this too extensively, if you want performance, because this is actually something people often forget about Varnish and edge set includes is they're not processed in parallel. So if Varnish sees a page and it has 10 edge set includes, it will go over the first one, wait for the response. Once that's returned, it goes to the second one. It doesn't go to all the edge set includes in parallel. So always keep that in mind. So you can actually make your website slower if you use a lot of edge set includes. The other thing, or the important thing when I mentioned earlier, I wanted people to test what happens if you add an Elasticsearch node, etc. I want developers to be in charge. What became really helpful was automating everything. So you use continuous integration, use Jenkins, maybe or Travis. You obviously, because you're really good developers and you read the manuals and you have modern styles of programming, everything is in bundles, and all the bundles have their standalone tests, and they can run standalone, and there's fixtures, and there's unit tests, and there's integration tests, etc. Right? Very good. So if we have two staging environments, actually, they both run on the same physical server. One for unstable, it's just a bleeding edge that's automatically pushed out every time a build passes. And the staging environment, which is just comes from the current release branch. It's all handled in Capistrano. And every single server we have is provisioned using Puppet. Save for a few firewall rules, etc. on the ISP side. But this actually allows us to bring new boxes, be it physical servers, which doesn't happen that often, obviously, or containers on the virtual machines on the staging environment, which you could use Zen or something like this, or VMware. We use LXC, that's like a kernel jail Linux containers, a kernel level virtualization in Linux, up really, really quickly. Because what we want to make sure, and this is also something you should need to make sure, once you have things like a share nothing architecture, replication, failovers, etc., it doesn't help you if you only run that in production. You want that at least in your staging environment. So what we actually do in our staging environment, it goes through the same physical load balancers, all the traffic, as the production traffic. But even a developer locally should never hit one virtual machine that runs Elasticsearch and MySQL and Nginx and PHP and some sort of weird proxying that makes everything magically work, right? There should be an instance that runs a load balancer. There should be two nodes that run MySQL with some sort of replication. There should be at least 2 nodes with Elasticsearch, because then he can go ahead and maybe just use Vagrant and switch off one of these boxes and see, does it work? Is the system still up, right? And that is, especially in our case, we use managed hosting, so this gets the developers in the right mindset, because what we had before that when we just ran the standard software is that there was a problem and they blamed the hosting company. They said, oh, they misconfigured something. But now they actually own everything, because they have the same Puppet manifests that they use in production to provision boxes. And if they see that something is wrong about an Nginx config option somewhere, right, they can fix it. They can test on their local machine, does it work? And then we theoretically have the ability to try that out on staging environment directly before telling the hosting company to push it to production. In that case, we used VWE, which is really useful. There's also Bento, but that's very focused on Chef, to build a base box, a Vagrant base box, that mirrors the production configuration more or less exactly, save for some IP addresses, etc. And then with Vagrant, we use all the Puppet manifests we have from production, obviously with a few customizations, again, IP addresses, usernames, passwords, etc., for all the developers. And then if a developer wants to test 10 front-end nodes instead of 2 or 3, he just adds a few nodes to the Vagrant file, and boom, there's going to be 10 of them when he types Vagrant up. So you obviously need a little bit of RAM for that, for the developers' computers, but RAM is so cheap these days, it's actually worth it. And all of a sudden, they're in charge of things. They can fix parts about the infrastructure, they have to understand them to work with it. And that really helps to get everybody on the same side. You don't have any finger pointings anymore between developers and ops guys, etc. It's been quite nice. What we want to do with this in the future is we want to run this staging environment itself using Vagrant LXC, which is a plugin for Vagrant that uses Linux containers, one of the new providers, what they call them. because then we could give developers actual physical access to the, well, not physical, but logins for the staging server and allow them to quickly kill off individual containers just for everybody in the company to simulate outages of certain system parts, etc. Other bits that have been really useful for us: measure, log, and test everything. In this case, I mean everything. There's no red crossing out. Profile your code. Like the web debug toolbar, as nice as it is often not enough. You want to use xhprof. You can compare runs. Before you make a change and push out a change, you can see what the impact actually is. You can run xhprof in production, maybe for certain IP addresses or a subset of your traffic. Log all errors, log all performance metrics, log the flow of users, log all access logs, and retain that data. This is really important. Put it somewhere. Put it on tape, print it out, and put it in, well, that's probably a bad idea, printing it out, but like put it in a Hadoop HDFS. If you want to later run analytics on it, HDFS or Logstash or something is really useful because you also want to empower developers to use that data, right? They don't have to make weird assumptions about, I think this is going to be the amount of traffic on that component, etc. They can actually look at it. And in our case, we did run a few on smaller TV channels, TV ads before the big primetime ones. The first one's going to be airing next week. But the small TV spots, they just give you fewer people browsing the site, but their behavior is roughly the same. They all go to the front page and then take a certain flow. So you can feed that information to a Siege or JMeter or Tsung script that will simulate the traffic accurately on your site. Because maybe your assumption is that 50% of the traffic is the home page, when in fact it's 95%, right? And then you put your priorities wrong. We actually saturated our network connection before the site would go down. So, you know, like the number of connections an individual computer could open and try to get the site to collapse under the load. So you can use MicroArmy or another tool like Bees with machine guns, which is pretty cool, to run Siege, or like it's an Apache bench that runs on EC2 micro instances, right? So you pay $2 and you have 100 boxes that quickly launch this huge amount of traffic against something. And remain focused in the things you do. So outsource the parts that you don't like to do, that are always tedious. Any sort of storage and backups. So we use S3 for a lot of user uploads, not user uploads, but lots of uploads, temporary data, etc. From imports, content delivery. This affects your ability to quickly provision instances. If you only deploy your code, but not like your couple gigabytes of assets, because they're already in S3 with a CloudFront CDN in front or something, everything gets a lot faster. With S3, you don't have to worry about backups because the reliability of the data is like 1,500 nines or something like this. Transactional email, for instance, another one, a good one. You don't have to worry about, did my email get delivered? Spam. You're not in the business of running an email delivery company that tries to avoid spam, etc. We use Mandrill, but Postmark or SendGrid do the same thing. These services will make sure that your email is delivered accurately, sender, profile, framework, or whatever it's called, DKIM signatures, stuff like this. They all have APIs. There's a REST API that you use to send an email, which is extremely stupid, because then you need to run your own Gearman where you queue up the email to send against the slow API. But they all have SMTP gateways, so what you should do instead is run a local sendmail or QMail or something that has a relay configured, and that relay will send all the email you deliver locally to a local host out into the cloud. Monitoring, we use New Relic, really happy with this. You can build fancy dashboards for management. They like it, they see stuff is up and has decent response times. You can measure a lot of things. Same thing for Logly, they have integration with each other, Silverline for tracing errors, etc. So yeah, that's pretty much it. This is the end. There are no questions because it's a keynote slot. I run out of time and I want breakfast. You can still ask me questions later. I think this is very good. It's 37, 2 minutes, I'm sorry. Thanks for listening. This was my talk, and enjoy the rest of the conference.